In the previous lecture, we saw how to install Python on Windows and then how to work with Visual Studio Code Editor using Python extension on Windows. In this one, we'll be quickly taking you through Python installation on Mac and then working with Visual Studio Code Editor. So in order to install Python on Mac operating system, here you can go ahead and download the relevant version. For instance, you can click on this Mac OS X and then download the version 3.7.4. Once you have it, you can just install it like a regular package that you install on Mac operating system. And after that, you can open up Visual Studio Code Editor, and there you need to ensure that you have this Python extension installed. In order to do that, just click on the extensions button, and there you can search for the extensions in Marketplace. Search for Python from Microsoft. And once you have installed this, all you need to do is ensure that your Visual Studio Code Editor path is included in your Mac operating system environment variable. So the path environment variable that you have on your Mac operating system must contain the Visual Studio Code installation path. And to do that, I would recommend visiting this URL, code.visualstudio.com/docs/setupmac. You can see how we can launch it from the command line. Here you also find the code to manually add VS Code to your path using this command. And that's pretty much it that you need to do in your Mac operating system to work with Python. Now that we are through with that, I would like to take you through the basics of Python and how it is different from conventional programming languages like C++, Java, and all. Now over here you can see that we have created a variable, hello world. We have not defined its data type, but here it is assuming that it is going to be of type string. One more thing you would notice is that it does not end with a semicolon, just like how we used to have it in C++, C#, Java. So here you won't find that. There will be no braces or semicolons, and everything here is an object. If I put an indentation over here, it will have some meaning to it. It's not like just for making the code readable, but it will also have some other meaning to it as well. So we'll be basically covering language overview in upcoming lectures in this section. In this lecture, we'll take a look at how we can download Python 3.7.4 on Windows operating system. So in order to download, we just need to go to this URL python.org/downloads, and here click on the download Python. If you want to download it for Mac or Linux, you can just click on the respective link to download it. So let's click over here now, and you can see the executable file is now being downloaded. Once downloaded, you just need to click on this one and it will start installing the executable. Here don't forget to add Python 3.7 to path, so select that as well and then select install now. Click on yes, and you can see it says setup was successful. Just click on close now, and that's pretty much it as far as installing Python is considered on Windows operating system. Now here, if you go to advanced system settings, click on environment variables. Here you will find the path variable, and you can see that the Python is now part of the path environment variable setting. Now in the next lecture, we'll see how we can write Python scripts using Visual Studio Code Editor. In this lecture, we'll explore how we can work with Visual Studio Code Editor to write Python scripts. The first thing that we did in the previous lecture was installing Python and ensuring that the route to the Python DLL executables are mentioned in the path environment variable. Once that's done, we need to open our Visual Studio Code Editor, and here on the welcome page you will notice that it has got this support for Python. So let's click on that, and here just click on OK. So now you have Python installed in your Visual Studio Code, and if you want to verify it, you can go to extensions, and here you'll see the list of extensions installed in this. There you go, we have Python extension installed in our Visual Studio Code. Now, other way of verifying it is by going to terminal and clicking on new terminal. So this is going to open a PowerShell window, and here you can type py-3 and then -- version. So this will give you the Python version that's installed. So we have Python 3.7.4. Now we have already created a workspace directory, Python scripts. Now what we need to do is type a command over here inside the directory, and we'll say code dot, press enter. Now as we know that Python is an interpreted language, and in order to run our Python script or code and get Python IntelliSense, we must tell the VS Code which interpreter to use. Now to do that, we'll be using the command palette, and for that you need to press Ctrl+Shift+P, and here you'll see the command palette appearing. There you need to write Python : select interpreter. So this is the command that you need to select, and here you can see these are the two versions of Python that we have in our system. The one which we need to use is 3.7.4 32-bit. So select that. Now that we have our interpreter set, we'll now go ahead and create a new file over here, and we'll name this file, let's say, as hello world.py. So py is the extension for Python scripts. Press enter, and this is going to open up. Here you can see linter also needs to be installed, so you can just click on this, install linter, and that will be installed as well over here for this project. Now that we have our file opened up, and here you can see the installation is going, and now that it's complete, what we need to do is just over here we'll declare a variable. So this is a sample example just to show what Python script looks like. So we'll say hello and then world, which is the plain old example, and this is a variable. Now what we need to do is print. So here you can see the IntelliSense is now appearing and print is coming up. So here we'll say print, and whatever we need to print is going to be as a parameter over here inside this function. So we'll say message is what we need to print. Now as far as IntelliSense goes, we can see that if I go here and say msg dot, you will get all these string methods, because the variable msg is for now containing hello world, which is a string, and that's the reason why you see all these string methods appearing when I type msg dot. Anyway, so let's remove this now, save this file. Now in order to run this Python script, all we need to do is right click and select Run Python in Terminal. Press it now, and here you go. You're getting the output as hello world. So you can see that working with Visual Studio Editor and Python is quite easy, and we'll be exploring more on this in the upcoming lecture. In the previous lecture, we saw how to install Python on Windows and then how to work with Visual Studio Code Editor using Python extension on Windows. In this one, we'll be quickly taking you through Python installation on Mac and then working with Visual Studio Code Editor. So in order to install Python on Mac operating system, here you can go ahead and download the relevant version. For instance, you can click on this Mac OS X and then download the version 3.7.4. Once you have it, you can just install it like a regular package that you install on Mac operating system. And after that, you can open up Visual Studio Code Editor, and there you need to ensure that you have this Python extension installed. In order to do that, just click on the extensions button, and there you can search for the extensions in Marketplace. Search for Python from Microsoft. And once you have installed this, all you need to do is ensure that your Visual Studio Code Editor path is included in your Mac operating system environment variable. So the path environment variable that you have on your Mac operating system must contain the Visual Studio Code installation path. And to do that, I would recommend visiting this URL, code.visualstudio.com/docs/setupmac. You can see how we can launch it from the command line. Here you also find the code to manually add VS Code to your path using this command. And that's pretty much it that you need to do in your Mac operating system to work with Python. Now that we are through with that, I would like to take you through the basics of Python and how it is different from conventional programming languages like C++, Java, and all. Now over here you can see that we have created a variable hello world. We have not defined its data type, but here it is assuming that it is going to be of type string. One more thing you would notice is that it does not end with a semicolon, just like how we used to have it in C++, C#, Java. So here you won't find that. There will be no braces or semicolons, and everything here is an object. If I put an indentation over here, it will have some meaning to it. It's not like just for making the code readable, but it will also have some other meaning to it as well. So we'll be basically covering language overview in upcoming lectures in this section. Now in this lecture we'll be starting with Python anatomy, and we'll be first of all covering how comments are defined in Python and what are import statements. So in order to comment a line, you just need to type hash. So basically these are Unix based statements. In Unix we have the hash used as comment to comment a particular line or command, like in cron jobs and all. So here also we are following the same pattern, and whenever you have to comment something, you can just type hash before that, and that line will be treated as a comment. Now you might come across certain comments which are at the top of the page with this signature. That is, the file will have this statement at the beginning of the file, and these will be the two characters that will appear first. This is known as shebang line, and these are usually used to define the interpretive path that the file will use to execute the code. But here we don't need it. Was just interested in giving you the detail about different types of comments that you may come across, but the standard is this one, hash, and that comment set. Now next we will be covering import statement. Now whenever you have to import some modules from Python, or you have to create your own and then import it in some other file, you make use of import statement. So we say import and then the name of the module which you want to import. For instance, over here we'll say platform. Now platform is the basic module that comes with Python, and one can make use of this platform module to get the Python version that is installed. In order to do that, we'll be making use of the print command, and here inside print we'll have platform dot, and then we'll have the Python version. So here you can see the IntelliSense is giving me the Python version link. There we have it, and since this is a method, we'll have it as a bracket, and that's pretty much it. Let's save this and run this file now. Here you can see the version is printed as 3.7.4, and then the next message hello world is printed. So we can have multiple modules imported using the single import command, or we can have multiple imports for specific modules that we want to import in our Python script. On the next one, we'll be taking a look at expressions and statements in Python. In this lecture, we'll be taking a look at blocks in Python. So earlier when we were discussing about Python, we mentioned that it does not have any curly braces to mark the start and end of a function. Over here you can see we have a function called main, which in turn calls a function called greet. Now how I can say so that the main method is calling another method called greet? The reason is this indentation that you see. So inside this main function we are calling this greet, and similarly inside the greet function we are calling this print statement. You'll notice that main is outside, so even if I take it from this line and put it at line number 8 and save this, if I run it, the main function will be called first, and Mind you that this is not part of the greet method. So let's run it now. And here you can see it says hello world. So that shows that main method is being called first, then it calls greet, and greet finally prints this hello world. Now if I have to put more line of code inside a given function, I can do so by putting another line over here. So this again is now part of method greet. So here, let's run this after saving it. And you'll notice that we are now having hello world and hi as the output. Now if I have a condition, for instance if true, in that case I can print true, otherwise I can print false. So now here this print true that we are seeing is inside this if block, and similarly this print false is inside the else block. So now if I run this method main over here, it will call greet, and greet will then run this. So we'll have these two lines printed, and then based on the condition either true or false will be printed. So over here we'll have three lines: hello world, hi, and then true. Let's run it now. So here you can see it says hello world, hi, and true. So this is the statement that gets executed. So if I change it over here as false and then run it again, the main method will then call greet, and here you can see it now prints false. So you can see that the indentation that we are giving is actually deciding whether a given line is a part of a method or of a condition or not. And based on that, it holds a very important place whenever we are writing Python script. So coming from other languages, if you're coming from C# or C++ side, the indentation was not of that much importance apart from making the code readable, but here it has got some meaning to it. And that's the reason why you should be aware of the indentations whenever you're writing a method or a condition. One more thing that we covered in the previous lecture was comments. Now here we saw how a comment can be written. The only thing I would like to mention in this one is that there are no multi-line comments. So if you have to comment multiple lines, you can do so as we are doing over here by prepending pound or hash key before the statement. So that was all about blocks in Python. In this lecture we'll take a look at how we can pass multiple parameters to a print function and use it to print multiple variables all in one method itself. So till now we have seen over here, like at line number 3, we have a print method which just prints the Python version, and then we have another print method which prints the message. So what we'll be doing over here, let's have another variable. Let's have it as a numeric x50, and now I have to print that along with this message. So what I'll do is I'll format it in this way using the F as the formatter, and then inside single quotes I'll be putting this message inside curly braces, and then another variable which I need to print. I can do it in this way, and let's save this and run it. Here you can see it says hello world and then 50. So F is basically a format method which is available with type string. So here if I have to do this, I can do the same using the format method, and the format method basically works in this way. So we have, let's say, hello string and then a placeholder, and we can make use of the format over here, and let's include something like 20, and then use this as a message over here. So another print line I'll take on top. I'll write print, and now I'll just print the variable message like we had it earlier. Save this and let's run it now, and there you can see it is doing the exact same thing, but now we are doing it via the string format method. And this over here you can see is much more beneficial whenever you are making use of a print method, even though it is also doing the same thing, formatting the strings. So that was string formatting in Python. In this lecture, we'll be exploring blocks and scope of variables. So here we saw what exactly a block is whenever it's a function. But what we are going to do over here is we'll be creating a new block altogether. So here I'll say this is the block that we have, and you'll notice that if the condition is true, we are having print true, and then there are some white spaces, and after that at the same indent level we have another line. So what does this mean is that these two lines are part of the same block. So when we'll run this, you'll notice it says true and this is true. So white spaces does not make any difference to a block if the indentation level is exactly the same. Now one more thing I would like to highlight over here. Let's say we have a variable over here called x is equal to 10, and then another variable which we define inside this block as y equals 20. Now if I go over here and print y, you can see that when we are printing it over here, value of y is format y. Let's run it now. You'll see that it says value of y is 20. So in Python, a block does not define the scope of a variable. In Python, functions, modules, objects, they do define the scope of a variable, but a block never defines the scope of a variable, as you can see from this example. So that was about blocks and scope of variables in Python. In this lecture, we'll be taking a look at conditionals in Python. We will be primarily covering if, else, and elif conditional statements in this lecture. So here you can see we have one file called conditionals.py, and the variables in this file like x and y, x is equal to 20 and y is equal to 10. Now here if I say if x is greater than y colon, and then this line that comes below it is an associative block where we are formatting and printing the result saying x is greater than y. X is obviously the placeholder for x, so it will print 20, and y is y with a placeholder, so that is going to print 10. So if I run this one, you can see that the output says x is greater than y, x is 20, and y is 10. Now if I have some other conditions like x is less than y, in that case I can again print a similar line over here, and this time we'll say x is less than y and rest of the things remain same. Let's go ahead and here make it 10 and this as 15. Save this and run it now. You can now see the output as x is less than y, x is 10, and y is 15. Now we can have another statement, elif x is equal to y, and in that case we can say x is equal to y, and x is this, and y is again the placeholder. So here let's make y as 10, run it again, and this time you can see the output says x is equal to y, x is 10 and y is 10. Another type would be saying else, and we can then print something else over here, so we can just write something else like this. Here you need to put colon, and if I just comment this line and now print this output, here you can see it says something else. So that is one way of printing it and making use of if, elif, and else conditional statements. Now one thing I would like to highlight over here is that in Python we don't have switch case statements. The reason for that is if you look closely at this if else statement constructs that we have, these are as good as switch case statements in itself. And that is the reason why we don't need a switch case in Python. Now we'll be covering more conditionals in upcoming lectures. In this lecture, we'll be exploring loops in Python. There are two kinds of loops that are available in Python. First one being the while loop. Now, the while loop executes till the condition is satisfied or is true. So over here in this example, you can see we are initializing the variable I with 0, and then we are saying while I is less than 10, print I, and then increment it by 1. So it will keep on running till the time I is less than 10. So if I execute this, you'll notice the output is coming as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that till the time I was less than 10, this loop executed. Now, the other loop that we have in Python is the for loop. Now, the for loop basically iterates over a list of items. So it could be an array which you can iterate over, or it could be a list of numbers. For instance, over here in this example, you can see that we have a for loop where we are saying I in, then we are making use of a range function. So it's a mathematical function provided in Python, which is just giving you a range of numbers, so 0 to 10. So we are saying that for I in range 0 to 10, print the loop. And if I execute this one now, you'll notice this for loop 0 till for loop 9. So that's how it is iterating over the list of numbers that the range method produces. And similarly, we can make use of the for loop to loop over array items or collections, which obviously we'll be covering up in the upcoming lectures. But to demonstrate, this is what Python provides as far as loops are considered. In this lecture, we'll be exploring functions in Python. In order to create a function in Python, we have the syntax which starts with def, then the name of the function, and parentheses. Parentheses is mandatory, and even if you do not have any arguments to pass to your function, you still have to provide it, and then a colon. After that, you need to write the function definition. Now, functions basically helps you to create modular code and reusable code. So you can create a function and you can use that piece of code time and again wherever you find it necessary. So it's like code once and use it a number of times. It just saves you from doing the same repetitive tasks time and again. Now, here you can see I have a function called main, which is in turn calling a method called greet. Now, if I have to pass a parameter over here in greet method, let's say a number. So I'll say n, and here I need to show that number. So I will format it using the technique that we discussed earlier. And here you can see it's a squiggly red line is appearing because this method is expecting a parameter, and here we have not provided any. So here I'll just print 10, and now you can see that line has gone. And now if I run this, you'll notice this line hello world, and then the number 10 is appearing. Now what if I do not provide it a number? Obviously it will be an error, but there might be a scenario where you don't have to pass a number, still you want this method to execute properly without throwing any error. In that case, you just specify a default value, and when you do that and run the application, you'll still get the output. And here you can see that we're not providing any value to greet method. So here it says hello world, and this time this 10 is coming as a default value. Rest of the stuff in functions we have already discussed in previous lectures, like the block that it contains. For instance, this greet method is having all this piece of code, and this main method is having greet only. So the indentation basically ensures the block that the function contains. One more thing I would like to highlight over here is that every Python method that we create returns a value, even though if you are not assigning that return value to a variable. For instance, this greet method does return something, and here in this case it will say none. So if I go here, let's call x equals greet, and here I will say print x. Save this and let's run it. I already had a variable with x, so I just renamed it to temp. Now here you can see that the squiggly icon is again coming up. It says assigning result of a function call where the function has no return. So let's run this now. And here, even though you're getting a squiggly icon, you can see that it is returning none. Now if I go here and say return n, and this time you'll see the red color squiggly icon has gone now, and the print temp method will now have an output. So let's run this again, and this time you can see the output is coming as 10. So that was introduction on functions in Python. In this lecture we'll be exploring classes and objects in Python. So classes are basically definitions and objects are instances of classes. So if I have to create a class in Python, for instance, let's create a student class. So I'll say class and then the name of the class. So here the name of the class is a student. Then you need to put colons, and next here in your class you can have attributes like name of the student, date of birth, email ID of the student. All these things can be provided as a student attribute. So here I'll say name of the student, and let's initialize with blank. We'll have address of the student, and after that we can also have some methods using which we will retrieve the values of name and address that will assign after creating an instance of this class. So to define a method or a function in Python, we'll make use of def and the name of the method. Let's say get name, and here the first parameter that we provide to a class, method or function is self. Now it's not necessary for you to give this name self. You can give it XYZ or anything you like, but as a convention this is followed. So in other code that you will come across, there you might see self written as the first parameter, and that's why you should also follow the same convention. Now we have self over here as the first parameter, put a colon, and then let's write print, and here I'll say self dot, and you can see address and name are coming up in the IntelliSense. So I'll say print the name, and let's save this. So now we have a method which prints name of the student. Similarly, I can create another method, and let's call it as get address, and here I'll say self. Again, this time we'll say print, and here we'll say self dot address. Save this. Now is the time to create the instance of this class and make use of these methods. So what we'll do is we'll create another method called main, and inside the main method we'll be creating an instance of the student class. So we'll say student is equal to student, next student dot, you can see student dot name as, let's call it as John, and then we'll have student dot address. Here we'll say USA. Now I want to call the method getName, so we'll say student dot getName method, and then I'll call student dot getAddress method. Save this, and let's call the main method and run our program. And here you can see the values are now being printed, the name of the student and the address. So that's how easy it is to create a class and make instance of that class as object and use it in Python. We'll be covering more on these topics in upcoming lectures as well. In this lecture, we'll be covering the fundamental data types that Python provides or supports. So here you can see we are assigning certain values to variables, like over here. For x, we are saying that the x holds an integer value of 10. Then we have y as 10.0. So here on hover, you can see that the data type of that particular variable is also shown. So here if I hover, you can see integer. Then here it says float, and then if I see hello world, it is a string or str, and then when we are assigning this true to variable b and none to variable z, we can run this to see exactly what all data types it has got. So x, as you can see, is integer, then y is float, and over here n is string, b is boolean, and then z, where we say z equals none, that is for none type. So these are the fundamental types that Python provides, and we will be exploring these fundamental types in details in upcoming lectures. In this lecture, we'll be taking a look at multi-line strings and formatting strings. So here you can see we have a variable called hello world, and this is placed inside single quotes. Now here in Python, we can have the same inside a double quote or even inside triple single quotes. So it doesn't make any difference, but if you want to have multi-line strings, what you can do is put your string inside either triple single quotes or triple double quotes. So here I can see hello world, this is a multi-line string. Let's save this and see it in action, and there you go, it says n is hello world, this is a multi-line string. You'll also notice that the carriage return is also preserved, and it's not like it's printing it in the one line itself saying that the variable n just contains these strings, so it's preserving those carriage returns as well. Now coming on to the formatting, there are two ways. One we are obviously making use of over here by using the f word here to format the string. The other one is obviously using the dot format method. Now here if I have another variable, let's say a equals 9 and b equals 10. Now if I want to put it over here, I can do so in this way. So I can put b over here and I can put a over here. Let's run this and see the result. So it says 10, 9, and obviously the content is coming over here. So the next thing that we can do is, let's say you want to pre-fill or put some spaces before or after a given string. For instance, over here I want to put some spaces after the variable b, and I want to put some spaces before the variable a. To do that, we put colon and then less than, let's say 9. Similarly for a, I'll say colon and greater than 7. So now when I print this, obviously I need to save it first. You'll notice that when it says n is hello world, this is a multi-line string, and then it prints b. After b, you can see these are the spaces. So if you want to pre-fill this with zeros, what you can do is put 0 before the greater than symbol. And let's save this. And here you can see after 10 and before 9, these are the zeros that it has printed to these variables. So here what I've done is I have enclosed it inside double quotes so that we can see what exactly this is doing. So you'll notice that we have B as 2 digits and the rest of the space is then filled by zeros. So here you'll see 7 zeros coming up, and then the total digits over here or character count will be 9 that we have over here. Similarly, here you'll see that 6 zeros are there and then 1 digit, that is the variable A. So total it makes 7. So that is how this after and before is used while formatting a string. So that was multi-line strings and formatting strings in Python. In this lecture we'll be taking a look at the various numeric types that Python provides. For instance, we covered integer and float. So here you can see we have a variable x as 10, and this is of integer type, and here we have a variable y as 10.0, which is of float type. Now with Python 3, if you are dividing an integer with another integer, the result that you'll get is going to be float. So here you can see the IntelliSense shows it as int, but it's not going to be an integer. Let me show you by running it over here, and you can see that x is integer, y is a float, and then obviously 22 by 7 is type float. So here when we say type result, it is of type float. Then when we are doing a modulus, which basically returns a remainder, the result is integer indeed. Now the issue that comes up with floating point variables is that they go with precision rather than accuracy. So whenever money is involved, we need to have accuracy rather than precision. So to take care of that, we have something in Python which is type decimal. So here we say from decimal import everything, and then you can see that we are creating a decimal using a string. So we are saying num equals decimal and then 0.10, and over here we are printing that number, and you can see the result is 0.10 and the class is decimal. So whenever money is involved, like any transaction data you want to save or work on, then I would recommend going with decimal. So that was all about various numeric types in Python. In this lecture we'll be taking a look at Boolean data type. Obviously we covered the Boolean data type earlier in our lectures, but here we'll be also taking a look at what are the other data types which return Boolean value when evaluated. Now first thing over here, pretty simple, b equals true, and when we will print it out it will say b is Boolean and type is Boolean, class Boolean. So let's go ahead and run this and see it in action. You can see it says b is true and class is Boolean. That's good. Now let's see this one. This also is going to return true and evaluated as true because 10 is obviously greater than 6. So if I run this one, here you can see it says result is true and class is Boolean. Fine. Now here is the twist. When we say x equals 0, this becomes integer value. But if I say if x and then print true, else print false. In this case, you'll notice for x equals 0, the value that gets printed is false. So here we have false coming up as the result. Similarly, if I have a variable with value assigned as none, in this case also you will see the value is going to be printed as false. And here also the result type is a none type. Now if I say empty string and then I try to evaluate that, that will come to false. That's the reason why you're seeing false, false and false over here. Now if I go here and say x equals 1, so even though it's an integer type, if I run this one, you'll notice the value is coming as true. Similarly, if I put some value inside this variable and then try evaluating it, you'll see that the value again comes as true. So there are certain cases where different data types return a Boolean value. In this lecture, we'll be covering lists, tuples, and dictionary. These are known as sequence types in Python. We'll be starting with list. So here you can see I have created a list using the rectangular brackets, and this is like a sequence of elements 1, 2, 3, 4, 5 stored inside this variable called num, which you can see is of type list. The list basically provides us mutable function, so you can basically go ahead and change any of the values that resides in the list using the index position. So if I have to change the value 1 to 10, I'll say num 0 because that's the index position of 1 equals 10, and when I loop through this, it will print 10 instead of 1. Now with tuple, you can see that I've commented this line because tuples are immutable. So if I try doing this, I'll be getting an error saying that this cannot be changed. So let's go ahead and run this now to see num and tuple in action. And here you can see it says at line number 7, tuple 0 equals 7, object does not support item assignment. So this is something which cannot be done when it comes to tuple. Now with range, we can also create lists, but again range is also immutable, so you cannot do any kind of assignment with range. So here you can see there are 3 parameters that we are passing to a range function. Now these 2 are optional parameters. When you specify all 3, the first one means start with this, the second one means the end item. So range basically prints one item less than the one specified over here in the second parameter. So if it's 10, it will go till 9, and then this one becomes the increment. So it says that start with 1, keep incrementing by 2 till you reach this value. So basically it's going to print till 9. So now that I've commented it, let's run it one more time. And here at the end, which starts with R, you'll notice that it goes till 9, and here it starts with 1, adds 2 to it, 3, then 5, then 7, then 9. So kind of odd numbers. Now if you want to assign something to the range, in that case what you can do is convert this range to a list. So now we have a list, and this list can then be used. So in the first place, let's say I want to put 8, and now when I'll run this one, you'll see the output R is 8. So that way you can use range and then convert it to a list to make it mutable and then go ahead with the assignment. Now there's one more type called dictionary. Now dictionary is key value pair. So I can say dict equals, let's say A as 1 and then B as 2 and then C as 3. So this is a dictionary object, and dictionaries are also mutable. So if I have to say this dict of C, so C here is the key. Using the key, we are making changes to the dictionary value. So here I'll say 5, and now I can again go ahead and use the for loop, but here the for loop will be a bit different. So we'll say for and then key value in dict dot items. We'll loop through. So we'll say print and we'll make use of the format function. Here we'll say key is equal to key and then we'll say value equals to val. Save this and now let's run this, and here you can see output is coming as key A value 1, key B value 2, key C value 5. So that was lists, tuples and dictionary in Python. In this lecture, we'll be covering the fundamental data types that Python provides or supports. So here you can see we are assigning certain values to variables, like over here. For x, we are saying that the x holds an integer value of 10. Then we have y as 10.0. So here on hover, you can see that the data type of that particular variable is also shown. So here if I hover, you can see integer. Then here it says float. And then if I see hello world, it is a string or str. And then when we are assigning this true to variable b and none to variable z, we can run this to see exactly what all data types it has got. So x, as you can see, is integer, then y is float, and over here n is string, b is boolean, and then z, where we say z equals none, that is for none type. So these are the fundamental types that Python provides, and we will be exploring these fundamental types in details in upcoming lectures. In this lecture, we'll be taking a look at operators in Python. First of all, we'll be covering conditional operators, which are equal, not equal, less than, greater than, less than or equal, and then greater than or equal. Next, we have logical operators, and these are AND operator or AND NOT operator. So AND is like x and y, true if both x and y are true, x or y, true if x or y, and then not x, which is the invert state. Next, we have identity operators. So we can say x is y, which returns true if the same object, and x is not y, which returns true if not the same object. And finally, we have membership operators. So we can say x in y, which returns true if x member of collection y, and x not in y, which also returns true if x not member of collection y. So all these operators that we just discussed are used in conditional expressions, and we will be covering more of them in upcoming lectures. In this lecture, we'll be taking a look at the tertiary conditional operator in Python. And over here, you can see we have a variable called x, which is a Boolean variable, and its value currently is set to true. Then we have this statement y, where we say print when true, and then we say if x, else print when false. So when I run this, you'll notice it's printing print when true. This is the tertiary operator in Python, and whenever you are making use of a tertiary operator, else block will be mandatory. So even when you don't have anything to execute for else block, you can make use of none, like this. And let's print it over here. See, so this condition gets printed if the variable is true, otherwise the else block is executed, and else block is always mandatory whenever making use of tertiary conditional operator in Python. In this lecture, we'll be covering arithmetic operators in Python, And here is the list of all the arithmetic operators. We have addition, subtraction, multiplication, division, integer division, remainder, that's modulus operator. Then we have exponent, unary negative, and unary positive. Let's go ahead and take a look at all of these. So here we'll start one by one. Let's go with addition. So here I'll run this. So x is 10, y is 5, total is 15. Then we will have subtraction, x minus y, and the result, as you can see, 10 minus 5 is 5. And then here x into y. Let's run it again, and the result comes as 50. Then we divide this, x divided by y, and let's check it out. Here we have 2.0. So the result, as you can see, is coming as float. But if you want to go with the integer division, you can make use of // Let's run this now, and here you can see the output now is 2. That's an integer. Then we have the modulus operator, x modulo y. So this will be 0 because 10 divided by 5 returns no remainder at all. Then we have exponent, and here we have the exponent, x raised to the power y. Let's go with unary negative and unary positive. So for that, we'll have, let's say x is equal to unary negative, that's minus x, and similarly we'll do the same with y is equal to plus y. So here let's print the result now for these unary operators, and let's call it as x and y here, and let's see the output. So here you can see unary negative makes x as negative 10, and positive doesn't change at all because this is already a positive, so that remains 5. So these are all the arithmetic operators that Python provides. We'll be covering other types of operators in upcoming lectures. In this lecture, we'll be exploring bitwise operators in Python, and following are the bitwise operators that we have in Python: AND, OR, exclusive OR, shift left, and shift right. Now here in this code example, you can see I'm making use of hexadecimal literals to represent certain values. For instance, A over here, which in decimal stands for 10, and then we have 2 over here, which in decimal also is 2, and in binary it will read something else. Now here you can see I'm making use of this bitwise operator on these two variables I and j. So when I say I and j, the output that will come will be stored in this variable k, and when I run this one, you'll notice a couple of things over here. I'm first of all making this format expression, and the first line prints the numbers in hexadecimal format. It says I is, and then we say the variable I, and after the colon we have delimiter, that is 0 to x. So the total length of the digit that will be printed will be 2, and it will be prefixed with the value 0. The same goes for j and k. Then we are coming to the binary one. Here you can see the total length of the digit that will be printed is going to be 8 bits, and it is going to be prefixed with 0 as well. Now here if I see I is printed as 0a, then j is printed as 02, and k is also printed as 02. Here in binary you will be able to see how the AND is working. So the first thing, 0a is printed as 1010, rest everything is preceded by zeros. Then j is 2 basically, so in binary it is 0010, and you will notice AND prints it as 2, and that's the reason why in hexadecimal we were getting this result as 2. AND ensures that the bitwise, so here you can see bit position 1, and here also bit position 1, both are having values 1, and here there's the reason why you see 1. For every other place there is a inverse available. So at position 3 we have 0 over here, here also 0, and that goes as 0. then again we have 1, in the other one we have 0, so it gets negated, and here we come to 0. So 1 only will occur when both these variables will have 1s exactly at the same position, and that's the reason why it returns as 2 or 0010 in binary. Now if I go ahead and use OR operator over here and save this and run it now, you'll see that the output now is A, which is 10 in decimal, and in binary it's 1010. Now here you will notice whenever it's OR operator, in that case it ensures that if 1 is available at any given position in any of these variables, the output for that place will be 1. So here you can see at position 4 we have 1, and that's the reason why we are getting 1 over here, and then this position is 0, here also it's 0, so that goes as 0. Then again at position 2 it's 1 and 1, so it shows 1, and then again we have 0, 0, and here also it shows 0. So that's how the OR works. Then we have exclusive OR, which is the caret operator. Exclusive OR ensures that it is going to give the result as 1 only when either of the variables has 1 at a given position. So you will notice 1 is available over here at position 4, but it's not available at position 4 over here in the variable j, and that's the reason why it is printing it over here as 1. For every other place, either we have zeros or we have 1s at exact same positions in both the variables, and that's the reason why it just prints 0 for that. So that was exclusive OR. Then we have shift left and shift right. Let's explore that as well. And here what it does is it shifts the result to 1 bit towards left if we are making use of shift left operator. So here you will notice the output that earlier was coming for 2, 1010 has been shifted towards left, and if I go with shift right and run this one, you'll notice this value shifts towards right. So that was all about the bitwise operators in Python. In this lecture, we'll be taking a look at comparison operators in Python. So they are less than, greater than, less than equal to, greater than equal to, and not equal to. Now let's go ahead and see them in action. So here we have two variables, x equals 10 and y equals 5, and we're making use of the greater than operator. We say if x is greater than y, then we print yes, x is greater than y. Else we print y is greater than x. So if I run this, you can see 10 is obviously greater than 5. So running this will print this message, yes, x is greater than y. And here if I just reverse this number 5, and then over here I say 10, and then I run this saying x is less than y, and here we print this. So it says yes, x is less than y. So that was less than and greater than operator. Now we have less than equal to. So here I can say x is equal to 10 and y is equal to 10. This time if I run this and say run it now, you can see it says yes, x is less than or equal to y, because both are having exact same values. 10, the equal to over here in the condition matches, and that's the reason why it prints this line. Then we have greater than or equal to. So here again we have the same variables, x is equal to 10 and y is equal to 10, and if I run this, I'll just need to change this output so that it matches it. And this time if I run it, you'll notice it again prints the same line, yes, x is greater than or equal to y. Then we have the equal to operator. So obviously we have these two variables as x equals 10 and y equals 10. So here we have the equal to operator, running it now, and there you go. and then we have not equal to. So not equal to, if I say this is 5, and here I'll say not equal to, and let's run it now. Finally, over here you can see, yes, x is not equal to y. So that was comparison operators in Python. In this lecture, we'll be taking a look at Boolean operators in Python. We have AND, OR, NOT, IN, NOT IN, IS, and IS NOT. So IN is basically, it checks for whether a value is available in a given set. The NOT IN checks for whether the value is not in the set, and IS checks for same object identity, and IS NOT checks for not same object identity. Let's go ahead and check them out now. So here we have two variables, x set to true and y set to false. Then we have collection of fruits, and then a single variable, fruit set to mango. Using the AND operator, we see if x and y both are true, then we will be printing true, otherwise it prints false. So here you can see x is set to true and y is false. That means the condition is false, and this is what it will print. Next, if I have to check for OR operator, so I'll say OR, and now as we know that one of these variables is true, so the output will be true. Now let's run this, and there we have the output as true. And here we can also go with a single value using the NOT operator. So if not y, let's run this. That means if it's not true, which is the case over here, and that's the reason it says print true. Similarly, if I say not x, which means not true, which is going to be false in this case, and it is going to print false. Let's run this now, and there you can see it's printing false. Next, we will be exploring the IN operator. So I can say if fruit in collection, so you can see mango is there in the collection and it will return true. There you go, it says true. And now if I say not in collection and save this, let's run it. So you can see it says false, because mango is actually available in the collection, and that's why not in returns false. Now if I have to compare, let's say, mango with the index position of this collection 3, so here I can go ahead and say if fruit is collection of index position 3, so index starts from 0, 0, 1, 2 and 3. In that case, you can see mango and mango both are here, so in this case it's going to return true, as you can see over here, because their identities will also match, as Python only contains one variable of mango in its collection. So even though it's present over here and here, the IDs of these two will be same. And if I say fruit is not, and I change the index position to, let's say, 0, in that case you'll see false is printed. In that case you will see true is printed, because fruit is not over here apple. So mango and apple, they are different, and that's the reason why it says true. So that was Boolean operators in Python. Now that we have covered operators in Python, it's time now to learn about operator precedence. Over here, you can see for version 3 in Python, we have this list of operator precedence, and this is the order from lowest precedence to highest precedence, that is from least binding to most binding. So you can see all the expressions that are mentioned either in brackets or as array or key value or expressions. These all, like tuple display, dictionary display and set display, these all have highest precedence. and the lowest ones are lambda expression, if else conditional expression, or and not x, that is boolean or, boolean and boolean not. Then we have these comparisons like including membership tests and identity tests. After that we have the bitwise or, bitwise exclusive or, bitwise and. Then we have the left and right shifts, addition and subtraction, multiplication, matrix multiplication, division, and a remainder, that's modulus operator. Then we have positive, negative, and bitwise not, exponentiation, a weight expression. Then we have subscription, slicing, and attribute reference. So this is from lowest or least binding to highest precedence or most binding. What it means is, if in an example we see over here, you can see I have this expression which says 2 plus, then inside the bracket we have 3 into 5. So the precedence will be first evaluated over here, that is 3 into 5, because that's inside a bracket. So this will be like 15, and then that sum will be added to 2. So 15 plus 2, 17. So the output will be 17 over here. Let's run this now. And there you go. So that was just an example to demonstrate the operator precedence in action. In this section, we'll be starting with loops in Python. There are two kinds of loops available in Python. The first one is while loop, and here as you can see, there's a conditional expression which, if evaluated to true, then the body of the code executes, and it again checks whether the condition still remains valid or not, and if it is, then again the body will be executed, and only the body will exit if the conditional expression results to false. Next we have for loop. Now for loop is usually used with iterators, tuples, lists, and all those sort of data items. Here we can see that it's basically using a sequence, and every time the sequence is valid, it goes and executes the body, and when the sequence is complete, then the for loop is exited. So over here, let's say we have a collection like tuple with 4 items, so the sequence will be like 4, and for every item the body of the for loop will be executed, and once that sequence is complete, then the for loop will exit. There are certain attributes like break and continue which can be used in these loops, and we'll be taking a look at them once we are through with the while and for loop in upcoming lectures. In this lecture, we'll be exploring while loops. Over here, you can see that we have a variable I set to 0, and here we have a condition which says if I is less than 10, then print the value of I and increment it with 1. So if I run this, it will keep on printing I till the value it's set to 9, and here you can see the output 0 to 9. Now what it means is that the condition needs to be true in order for this line of statements to be executed. Let's take another example over here. So let's say here we have a password, and let's set it to some value random, and once that's done, let's ask the user to enter the password. So here I'll say input is equal to blank. Now I'll say that keep on asking the user till correct password has not been supplied. So here I'll say if while input is not equal to password, then ask the user to enter the password, and to do that we'll be writing input enter password. Let's save this and run it now. So here this looks like a reserved keyword, so I'll change this to input, that is INP, and here also we'll put as INP, and here as well. Now let's go ahead and run this now. here you can see it says enter password. Now if I enter anything random and press enter, and here you can see it says enter password. Now if I enter any random value and print this, you'll see that it is again asking for the password. Now let's go ahead and enter one more time a wrong password. You can see that it's still going and asking for the correct password. So now we'll be entering the correct password, that's random, and let's press enter now, and there you go. As soon as the correct password was provided, the loop exited. So we saw two implementations of the while loop over here, one with a collection, that is where I was set to 0 and we wanted it to print till 9, that is I less than 10, and then another set where we ask the user to enter a correct value based on which the loop will exit. And by the time the user was entering wrong values, the while loop was executing. So that was while loop in Python. In this lecture, we'll be taking a look at the for loop, and here we have two examples to demonstrate working of for loop. The first one is the range method, where we insert the start and end item, and the loop for, as you can see over here, loops to or iterates through all the sequences that the range method produces. So when we say 0 to 10, it actually produces 0 to 9. So here the value that will be printed for I will be from 0 to 9. Similarly, over here we have a tuple, which you can see as 1, 2, 3, 4, 5, and we can access each element of the tuple using the for loop. And here we have the syntax for it: for t in tuple, and then whatever is the value of tuple that gets printed over here. So basically it's going to print 1, 2, 3, 4, 5. So let's go ahead and execute this now, and there you go. You can see for the first range method it says for loop 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then for the tuple example we had, it says 1, 2, 3, 4, 5. The value of t is 1, then 2, 3, 4, and 5. So that's what for loop is. In the next lecture we'll see how we can control the functioning of while and for loop using break and continue statements. In this lecture we'll be taking a look at loop controls which are available with for as well as while loop. Here we can see that continue, break, and else are the controls which are used to modify the behavior of while and for loop. So when we say break, the loop exits basically. So whatever is inside the body is not executed at all, and loop exits. When we say continue, the certain portion of the body is not executed and the control goes back to the body and starts afresh. And else is executed only when the loop exits normally. So to explore this, we'll be going through an example which will make us understand the functionality of these three controls. Now here you can see that we have certain variables defined, like a password is set to random, then we have input variable, then we have valid set to false, count set to 0, and max allowed as 3. What we are trying to do over here is, if the password is incorrect, or if the password entered by the user is incorrect, in that case we are setting the counter value, incrementing it by 1, and we are checking it if the user has exhausted all its attempts or not. The max allowed value is 3. So we say if the count is greater than max allowed, it will just break. When we say break, it will exit out the loop and simply go to line number 16 over here, and it will say access denied, because valid is set to false. And here we are checking if valid true, otherwise access denied. Now when we say that if count is equal to 2 and continue, what it will do is it will skip this line 12 and it will go back to line number 1 and start afresh. So user will be asked to enter the password, and then the count value will be checked and it will again execute. Now if everything goes fine and user enters the correct password, the loop will exit normally, and in that case the else block will be executed, the value of valid with will be set to true, and then finally it will say access granted. So let's go ahead and take a look at it now. So here you can see first time it has executed, it says 1, enter password. Let's enter a password which is incorrect and press enter. You can see that it goes to 3 directly, because when we entered this password the loop was executed again, count was set to 2, and this condition was met, count equals 2, and set continue. So when continue was hit, this statement, line number 12, was skipped and it went again at the beginning. So here it again said the value count equals count plus 1, and it became 3, and since 3 is not greater than max allowed for now, we are getting this line number 12. Let's enter one more time a wrong password and press enter, and here you can see it says access denied because valid is still false, the else block was not executed. Now let's go ahead and rerun it one more time, and this time we'll be entering correct password. So here we'll say random, and there you go, it says access granted, because in this case the else block was executed and the value of valid was set to true, and finally it printed access granted. So this is how we can make use of loop controls to alter the behavior of for as well as while loop. In this lecture we'll be starting with functions, and we'll be covering how to create a function, how to pass arguments to a function, how to store return values from a function. But in this one we'll be taking a look at the stored attributes. For instance, over here you can see we are saying if name equals main, and in that case it should call the main method. So in order to create a function, we will have to make use of this keyword called def, which is define and then the name of the function. For instance, over here we have this function called main and then 2 parentheses. Here we can also pass a parameter. For instance, if I give this greet method a value 5, and here I can say that value as n. So this 5 will be stored over here in the variable n whenever the greet will be called over here, and we can make use of that by going to use the formatting, and here we'll say n like this. So we have the keyword def, then the name of the function, parentheses and colon. After that we'll have the body of the function. For instance, main contains another function call to a function called greet, and here you can see we are again creating greet method or function exactly like we have created main. Here we are using the def keyword, then the name of the function, and then parentheses, and inside that the parameter, and this body contains hi and then the parameter which we have passed over here. Finally we are on this line number 7, where we just check if the file is main file. In that case, call the main function, and this convention you will see more often whenever you'll encounter any Python code, and this is so common that if I go ahead and say double underscore, you'll see it is providing me this feature name. So using this approach, we are saying that if it's a main file, call the main method. And if I save this and run it, you'll see it's saying hi 5. So it calls the greet method, passes this value 5 and stores that value, and then prints hi 5. And this is the line which gets executed because this is the main file the main method is called. Now in the next lecture we'll be exploring more about functions. In this lecture we'll be taking a look at how we can pass arguments to a function, what are default arguments in a function, and what is call by value and call by reference when we talk about functions. So the first thing is passing arguments to a function. Over here you can see we have this main method which is calling greet method. Now greet is actually having one argument, that's an integer value, and here you can see that to receive that value we have a variable called n as function argument for the greet method. Now if I want to pass multiple arguments, I can do that by simply separating them with comma. For instance, here I have 3 parameters now, and the function must accept 3 parameters. If I try to run this right away, I'll be getting errors over here that takes 1 positional argument but 3 were given. So we have to kind of provide multiple arguments over here. Now if I run this, you'll notice it executes properly. So there are scenarios where you don't expect any value, but you cannot go ahead and modify the function altogether. So what you do is make use of default parameters. For instance, if you do not want to pass 12 and 13 and just want to pass 5, what you can do is you can assign some default values to these parameters. So the convention is whenever you are making use of default parameters, there should be the one at the end. So here you can see n is not a default parameter, so we have it at the first place, and then O and P are default parameters, so we are having it after the non-default variable. So I cannot have something of this sort. So if I have to have default variables, they need to be mentioned in the end. Now here you can see I am just having one variable, and here 2 of them are having default values. So running this will give you the output high 5. So that was how to pass arguments to a function, how to create default arguments. Now let's talk about call by value. So here you have noticed that I have passed this value 5, and when I'm printing it inside the greet method, I get this high 5. Now if I go ahead and print it over here, the same line, instead of n, I'll be just assigning this value. Let's say x is equal to 5, and then I'll be passing this x over here and the same x over here as well. Now let's run this. You'll notice at both the places it says high 5, high 5. And if I try to get the ID of this variable, and if I try to get the ID of variable n over here inside the greet method, you'll notice both of them are same. There you go. Now if I go ahead inside the greet method and change the value of n to, let's say, 2, and then run this, now you can see that these two IDs are different, and the value inside the greet method for n says high 2 and one over here says high 5. You'll notice the same value, x, was passed to this function greet, and later on it was changed to 2. So ideally it should have printed 2 at both the places after the greet method got executed, here as well as inside the greet method, but it's not doing so. The reason behind this is that integers are immutable in Python. So whenever you're creating a new assignment over here for a variable n, it will be assigned a new object altogether, and that's the reason why you're having a new ID, and that is why it's printing 2 over here and 5 over here. And that is what we call by value, because the value is being passed to this method greet for immutable data types. Now if I go with mutable data types, for instance lists, so let's create one over here. Instead of, let's say, have a list over here and assign it to value 9, then go ahead and assign the same value to a variable y, and then try updating the value of y at index position 0 to something, let's say 5, and here let's print that value of x as well as y. So I'll be commenting this over here, and this as well, and now all I need to do is print the value of x and y. So here you can see x, and then here let's print y, And now if I run this, you can see for both X as well as for Y, it is printing 5. And even if I pass this value over here, it will do the same. So let's do that now. I'll be commenting this and commenting this as well, commenting this. Let's call greet method, and after that call X. So here you can see X is this as a list, and I'm passing it for n and making it 2. So I'll just say at index position 0, and let's comment the ID of this. Now when I'll say print hi X, it will print 2, and here also it will print 2. Let's do that now. There you go, you can see it's printing 2 at both the places. And if I now print the ID of n and ID of X, you will notice these are the same IDs. And there you go. So mutable objects like lists over here are called by reference, and immutable ones are called by value. We just saw that in the example over here. In this lecture, we'll be taking a look at variable augment list features supported in Python. So over here you can see we have a function called main, and then we have defined a tuple which was having even numbers till 10. Next we are having a function called variable arguments, and you can see that we are passing a tuple over here as an argument, but before that we are also having this asterisk symbol or star icon, and when we do so over here, it means that the argument that we are passing is of variable length. So instead of a tuple, we can have anything comma separated over here, like list of strings separated by comma. And the same when received over here as parameter. You can also see that here also we have the asterisk symbol and then the args, args. This is the common convention to have variable augment list variables named as args. And then we are checking inside this if there is any item in that argument list. That means if the length of the argument collection is there, then we are looping through each one of them and printing them. Otherwise we are simply saying none. And here again we are checking if it's a main module, then call the main function. Now if I run this one, you'll notice the output coming over here 2, 4, 6, 8, 10. I can pass few more over here, just making it a general tuple now, and let's run it. So here you can see it's printing all those values. And this way, if there is a requirement where you are not sure about the number of arguments that is required to be passed in a function, you can make use of a variable arguments feature provided in Python. In this lecture we'll be taking a look at keyword arguments in functions. So over here we have a main function which is having a function call to var arguments function, and there you'll notice a special thing that we have over here is double asterisk and then kwargs. Now kwargs is a convention of writing keyword arguments, so it's like keyword arguments short form kwargs. And you can name it anything you like, but it's just a convention which I'm following over here. And you can see that when we are making use of keyword arguments, we are passing the variable name or parameter name and then the value that it is going to have. For instance, over here the variable fruit will have the value apple and the variable vegetable will have the value onion. Now this is basically a dictionary that we have over here. Let's go ahead and first of all run this. So the output, you'll see fruit, apple, vegetable, onion. And here what we are doing, we are checking the length of the argument, and if it is there, then we are looping through that argument set, and then we are just printing the key value pair in a way. So the key is this parameter fruit, and kwargs of a will basically give you the value for that parameter. So it says fruit, apple, vegetable, onion. Now if I just take this out from here and let's make it a dictionary. So here I can go and say d is equal to dictionary, and inside this paste this, and then here to pass it as keyword argument I'll just say **d. Let's save this and run it again, and there you go. You can see the same output is coming over here: fruit, apple, vegetable, onion. So basically the keyword arguments that gets passed to a function is nothing but a dictionary. So that was keyword arguments in Python. In this lecture we'll be taking a look at function return types. In Python, every function returns a value. So over here we have an example. For instance, you can see that this is the greet method that we have defined, and here we are trying to print the type of the return value and the value itself. So inside the greet method we are saying print hello, and then we are returning a tuple. Now this tuple is having these values 1, 2, 3, 4. So when I'm executing this at line number 9, the main method, x will be of type tuple and the value will be 1, 2, 3, 4. So let's go ahead and run this now, and here you can see it says hello, and then the class is of type tuple and the values are 1, 2, 3, 4. Now if I go ahead and just comment this line and then run this function, you can see now we are not returning anything per se, but the function still will return a value. Let's go ahead and check it out. What will be its type and what will be the value that it's returning now. So here you can see when there's nothing to be returned, the function by default returns a value of type none type and the value none. So that's how Python functions are a bit different from the regular functions that we see in other programming languages like C#, Java, where we can say that a function never returns anything like type void in that case. But here the function will always return one thing or the other, as demonstrated in this example. In this lecture we'll be taking a look at generators. So generators are basically functions which are going to return a series of numbers. For instance, over here we have this function called generate even, and you can see that we have provided a value to it like 20. So what this function is going to do is it will print out all the even numbers till 20. So we can increase that value as well, but for the sake of demonstration I have kept it to 20. Now over here you will see that inside this generate even method we are accepting this value inside a variable called range, and then we are starting our iterator I with 1, and it's going through till it matches this value range. So in this case it will be 20, and then we are checking if that number I is divisible by 2 and the remainder is 0. In that case we are yielding that value and then incrementing the value of I with 1. Finally, when we are executing this main method, the output will be shown. So all the even numbers till 20 will be shown. Let's go ahead and run this now, and here you can see the output 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So generators are helpful whenever you need a series of numbers to be returned by your function. In this lecture we'll be taking a look at decorators or wrapper functions in Python. So as we know that everything in Python is an object, so if we are creating a function, that is also a type of object in Python. So let's go ahead and create a simple function first of all. So here we'll be writing def greet, and this is a function. Inside this we'll kind of create another function. Let's call it as a decorator function, and this decorator will have a print which will say hi from decorator, and once that's done we'll be returning this decorator. Now here what we'll do is we'll create a variable called f, and we'll be assigning this greet method to that. variable, and finally we'll be calling this function f. So now if I save this and run it, you'll notice that it says hi from decorator. So what exactly is happening over here is that this is a type of object, which is a function, and we are simply assigning it to another variable. Now we're calling the same function using variable f. Now if you try and execute this decorator directly, or you try to assign it, so if I try doing this decorator, let me comment this one, save this, and let's run this. You'll see that the name decorator is not defined because this is inside the method greet. So obviously this is not going to work. Now next, what we will be exploring is if we have this greet method accept a parameter, let's call it as f, which stands for function. So what we'll do is here we'll be executing that function, and then we'll say print by from decorator. So you can see that these kind of wrappers are helpful when you are trying to work on some methods, and there should be some task that should happen before that method gets executed, and then there should be some task which gets after the method gets executed. So in those cases you can just make use of these wrappers. So that's why we are exploring this, and Python makes it really easy to create decorators or wrappers. So now here what we'll be doing is we'll be creating another function. Let's call it as demo, and here we'll simply say print hi from demo, and next we will be calling this greet method, and we'll be passing this demo inside it. And what we can do is we can either assign it to a new object like f over here, or we can even assign to the same demo method. So if I now execute this, what it is doing is it will first of all pass this demo function to this greet method, and then the decorator will be called, and it will simply run these 3 lines. So it will say hi from decorator, then the function demo will be executed, which will say hi from demo, and then it will say bye from decorator, and then the result will be basically assigned to demo. So now let's go ahead and run this. You can see hi from decorator, then hi from demo, and then bye from decorator. Now this looks a bit confusing. So what Python has done is they have provided decorators. So in order to ensure that this method gets called as a parameter by the greet method, we'll have this greet just above this function, kind of a placeholder. So now this demo will be passed automatically as a parameter to the greet method. So here, if I now call this demo, you'll notice that it automatically calls this line print hi from decorator, then the function gets executed, and then bye from decorator. So you can see that how easy it is to wrap a particular function inside a function using the decorator placeholder. In this lecture, we'll be taking a look at data structures in Python. We earlier covered these in overview section where we briefly discussed about list, tuples, dictionary. Now in this section, we'll be exploring them in detail. So the first data structure that we'll be covering in this section will be the list type. And as we know, the list is a mutable data structure, which means that we can add, delete, and edit list items. You can see that it is created using rectangular brackets. Next we have the tuple. Tuple is similar to list, but it is immutable. So we have tuple created using curly brackets, as you can see over here. The other data structure is dictionary, and this is a key value pair. So we have a key value pair within curly brackets. that's A:1, so that's A is key and 1 is the value associated with the key. Similarly, we have B2, C3. The other data structure that we have is set, which is exactly like tuple. So it's created using the curly brackets and it's unordered list of unique values. So we'll be covering all these in details in upcoming lectures. In this lecture, we'll be taking a look at the sequence types in Python, and they are list and tuples. Now, here we'll be covering list first, and all the methods except append and insert are available for tuples as well. As we know that lists are mutable and tuples are immutable, that is the reason why we do not have append and insert available for tuples. So here you can see that I have created a tuple called num, and this is having values from 1 to 5, and here we are just looping through it, printing all these values one by one. Next, over here you can see now if we have to print certain numbers from the list. For instance, over here I'm saying that I need to print starting from 1 till 4 every second item in the list. So it's gonna print 2 and then 4. That is what this is going to do. And these values, the last one, is optional. So you can specify a range like 1 to 4, and then you can also specify the increment value. Next we have search function. So if you want to find out the element exists in the list or not, you can specify that value, and if that value exists in the list, its index position will be returned. So here we are making use of the index method, and there you can see index starts from position 0, so 0, 1, 2. So index position of 3 will be printed as 2. Next, as we know, lists are mutable, so we can add items to the list. If we have to add an item in the list, at the end we can say num.append and then the value. Similarly, if you have to insert something into the list at a given index position, you can specify the index position and then the value that you want to insert. So let's go ahead and see all of these in action, and then we'll move on to the remove and delete functionality. So here I'm running this now, and there you go. You can see the first one prints 2 and 4, index position is shown as 2, and then we have the count of num, that is, it contains 7 items in the list, and we can do so over here, and we can just print the updated list by going over here and saying for loop. Now let's give it a run one more time, and here you can see the value of I is being printed 1, 2, 3. You can see that the at index position 3 now we have 7, then 4, 5, 6. 6 was appended, and then we are listing through the tuple that we have defined beneath. Now let's go ahead and take a look at remove functionality. So if you have to remove a value, you can specify the number itself and say remove this, so it will be removing that value. Let's go ahead and check this in action. Here you can see the length is now 6, and when I'm looping through the list, you can see that 7 is no more part of the list. Other way of removing items from a list or tuple is using the pop method. The pop method, when no parameter is provided, removes an item from the end of the list. So if I go here and remove using pop, this will remove the last item in the list, which is 6 over here. So let's go ahead and run this now, and here you can see 6 is now not there in the list. It has been removed. Similarly, if you have to remove using an index, you can do that using the pop method by providing the index value, and if you want to use the index, you have the other option using delete method. So I can say delete num3, that is the index position, or delete num starting from 1 to 3. So here we are deleting a range of values starting from index position 1 all the way to 3. So if I see over here, starting from 1 all the way to 3, 4. So these values will be removed. Let's go ahead and now see this in action. So now the list which is printed, you can see the values have been removed from index position 1 to 3, and the updated list is shown over here 17456. Next we have join method. So if you want to print the list of items as a comma separated value or any specific separator that you want to include, you can do so using the join method. Over here, as we have the list of integer type, we have to convert it into a string type first and then use the join method, because join works on string items only. All these methods are also available for tuples, excluding the append and insert. We'll be covering more of the data structure types in upcoming lectures. This lecture will be covering dictionaries, which are another type of data structure supported in Python. And here we can compare dictionaries with associative arrays in other programming languages. In Python, dictionary is a collection of key value pairs. As you can see, we have a couple of ways defining a dictionary. For instance, over here you can see we can go with the tuple approach, where we have a curly bracket and then the keys are specified in a string and colon, then the values. So key values are basically separated by a colon. Other approaches by making use of the constructor method, that's the dictionary constructor method, and here we specify the key equals the value. So here we have a equals 1, b equals 2, and c equals 3. Once we have defined a dictionary, we have to take care of that the keys of a dictionary are immutable, but the values are not. So here you can see we can go ahead and update the value of key C to 5 instead of 3, and when we will run this, we'll get the value 1, 2, and 5 instead of 1, 2, and 3. In order to print the key and values of a dictionary, we have this for loop where we say dictionary.items, and then we can just print the key as well as the value. Now if you just want to print the keys alone, then we can do that as well by making use of dict.keys method, and here we are just printing the keys. Similarly, we can go for values as well. So here we can say dictionary.values and then print all the values. If you want to find out whether a key exists in a dictionary or not, one way is by making use of this in method. So here we are saying print a in dictionary. So if the key with this name exists in the dictionary, it will return true, otherwise it will return false. Now if you want to get the value of a key irrespective whether it exists in a dictionary or not without throwing any errors, in that case we have the get method. So we say dictionary.get and then the key of which you want the value. So here we have the key as z, and as you can see it's not existing in our dictionary. In that case the value of x will be none. So now let's go ahead and run this to see it in action. First we can see the key values are being printed, then key alone, and then values alone. Here you can see a exists in dictionary, so it prints true over here, and as you can see z does not exist in a dictionary, so that's why we get none. Now if I just go here and say a instead of z, save this and run it again, you'll notice the value is now being printed for the key a. So a holds 1, and you can see that the value of c was also updated to 5. So that was all about dictionaries in Python. In this lecture, we'll be taking a look at sets in Python. Sets are just like list data structures, and they also do not allow duplicate elements. So over here you can see we have created the sets like x and y using the set constructor method. So here we are saying a set with fruit apple and the another set with mango. Now when I will run this print set x and print set y, you'll notice that it is going to print only the unique elements in the set. For instance, for apple it will be just printing a, p, l, e, and for mango it will be printing m, a, n, g, o. So let's go ahead and run it. The ordering could be random, but you get the idea. So in this case, since P was defined 2 times, you can see that it is only appearing once in the set. Now there are a couple of methods which we can apply on set structure. For instance, if I have to find out data in set X but not in set Y, in that case I can simply say X minus Y, and let's go ahead and run this. And here you can see it is printing LEP. So if you see over here X minus Y, so data in set A is PLE, which is obviously not available in this set. And that is what is being printed over here. Now let's go ahead and see data in set X or in set Y. And here you can see the data in set X as well as in set Y. So it is like O, M, A, N, G, L, E. So in a way it is printing everything over here. Now if I go and say exclusive OR, that is data which is present in set X and Y but not both. So here you'll notice A is present in both the sets. Now if I run this one, here you'll see everything is printed except A. Now if I say print set X and Y, in that case it will print the character which is common in both the sets. So these are some of the methods that we can apply on sets, and obviously as we mentioned earlier that sets do not allow to have duplicate elements in it. And here we have the print set function. So all it's doing is looping through all the characters of a set. So when we are passing X to this particular function, it is just looping through each of the characters, and it is ensuring that the end of each character when printed is empty space. And finally it is just wrapping it around rectangular brackets. That's how you see it over here. So that was all about sets in Python. In this lecture we'll be taking a look at list comprehension. Now list comprehension is a concept where we generate a list from another list. For instance, over here we have a list generated using the range method. Now what we are doing next is we are creating another list called even, and for this list we are using the earlier list as a source. So we are saying X for X in the num list, and X will be shown here in this list when it is divisible by 2. So all the even numbers in this range will be part of this new list. We can also create a dictionary or tuple. For instance, here we are creating a dictionary using the same list. We're saying X as the key and then colon, and next we can see the value is X times 2 for X in num. So when we are generating or printing this list or dictionary, you can see that. So here you can see all the even numbers being printed: 2, 4, 6, 8, 10, 12, 14, 16, 18, and then the dictionary that we have created using the earlier list num. Here we have the key as 0 and value as 0, and then you'll see key will be starting from 0 till 19, and here the values will be multiplied by 2. So 1 into 2, 2, and then 2 into 2, 4, so on and so forth. And that is how easy it is to create list or tuples or dictionary using existing lists in Python. Python allows us to create mixed data structures as well. For instance, over here we can see we have 2 tuples defined, and even in those tuples we have a list included as one of the items of tuple. Now what we are doing over here is we are creating another list using these 2 tuples, and we're calling it as mixed, and you can see tuple 1 and tuple 2 are part of this list. Here we have created some print statements which is being used on these tuple1 and tuple2 to find out the types and the value that it contains. For instance, if I go ahead and run this, you'll find over here tuple1 this is the tuple and its type is tuple. Similarly, we have other set of print functions which are identifying the contents of those tuples. For instance, this tuple1 is having an integer, then a float or decimal value, and then we have a string, and then again integer, and then a list. So that is what we are doing over here. You can see tuple1 is 5, 5, and the type is list. Now finally, when we are on the mixed one, we are making use of isInstance function to identify the kind of data structure it is. So here we are saying isInstance mixed. In that case, we are just asking whether it is of type list. If yes, then it's printing mixed list. Otherwise, if it finds that the mixed data structure is of type tuple, in that case it's going to print mixed tuple. Otherwise, it will just print something else. And here at the bottom, you can see it says mixed list. So that is how we can work with mixed data structures in Python. In this lecture, we'll be starting with classes and objects. As we are already aware that everything in Python is an object. So that means its definition must be coming from some place, and that place is referred as classes. So in general, a class can have properties and functions, and as you can see over here in this example, we have a class called student, and it has got these attributes or properties called name and address, and then two functions, get name and get address. You'll notice the first parameter to these functions is an argument called self. Now you can name it whatever you like, but as convention one should follow naming these arguments as self. So the first argument to a class function is self, and self basically references the object that gets created. So over here when we are saying student.name and then we are saying student.getName, so the student object that is created is actually referenced by self. So when these methods are called, that object is basically referenced using the self argument. And here you can see we're just printing self.name and self.address. So these two methods has their definition. And finally, we have a main method where we are creating an instance of the student class. The name of the instance is student, and we are then setting these two attributes, name and address, and then calling these two functions, get name and get address. Finally, we are executing the main function. So if I now run this one, you'll notice it is printing this John and USA, and these two print statements were defined inside get name and get address method. So that was an introduction on classes. We'll be covering more on this in upcoming lectures. In this lecture, we'll be taking a look at constructor methods inside a class. So here in our previous lecture, we covered how to create an instance of a class and how to create a class with sample attributes like name and address. Now in this one, we'll be exploring how we can create a constructor in a class. So here we have the same student class, and you will notice a special method over here that's _init, and then certain parameters as part of that method like self, and then the attributes of that particular class like name and address. So here self.name equals this name that is being passed, and self.address is the address that is being passed over here. And then we have our usual get name and get address method. Now here, when we are creating an instance of a class student, we are passing these two parameters, namely John and USA. You'll notice there's no need to pass something for self. So you just need to pass the other two parameters that are required, name and address. So here John and USA. Now when I run this one, you'll notice the output coming as John and USA over here. There are times when you have a large number of attributes in a class, and providing them in this way will consume a lot of time. So to save that, we can make use of keyword arguments, and here we can make use of keyword arguments in this way. So now you don't have to pass John and USA like this. You can do it in this way. Name is equal to John and address is equal to USA. This way you will notice that it is more readable. We know what parameter we are passing, like name as John and address as USA. Now if we want to ensure that a default value is always assigned to a given attribute, we can do that as well by using something like this. So we can say if naming KW arguments, then whatever name is there, that will be assigned to name. Otherwise, let's change it to Matt over here and save it. Now if I don't pass name attribute and just the address, let's see what gets printed when I run this. You'll notice Matt and USA is being printed because that is the default value we are passing when name is not provided. So that's how easy it is to have a constructor in a class and use it when creating an instance of a class, as shown in this example. In this lecture, we'll be taking a look at how we can override our default print method whenever we are making use of classes. And here you can see that when we are creating an instance of a class student and providing some values like address over here, let's provide name as well, and these two things are then passed to this constructor, which is the init method. And here you can see we are passing the keyword arguments, and this basically assigns the name and address to these variables. We have functions as well, which currently just prints the name and addresses, and that is what we used in previous examples. Now in this one we are saying print and then the object itself, that is the student. Here you will notice that we have a special function which is _str_, and obviously as with other methods of a class, this also has a method parameter called self. Here what we are doing is we are simply saying return and then the format keyword, that's with F, the student name is, and then we are accessing the attribute self.name and the address is self.address, and this line will be printed whenever we call print statement and pass the student object. So if I run this now, you'll notice that it says the student name is John and address is USA. So this comes in handy whenever you're working with certain classes where you want to print specific output depending on certain conditions, and utilizing print in this way basically allows you to encapsulate your business logic within a class and its methods. So that was how we can override print method in a class. Now in this lecture we'll be taking a look at inheritance in Python. So till now we have created classes, and in those classes we have our attributes and methods. Now what if we need to have a common class, and from there we will be kind of using certain attributes or methods and using it in a different class. For instance, as an example, we can say that every student is a person, and every person has certain attributes. For instance, we have height, age and gender. So that is something which is going to be common across all students. These attributes are going to be there. So what we have done is we have created a person class, and in that class we have these attributes like height, age and gender. Then what we've done is we've created student class, and here you will notice one special thing. With the student class we are passing person as an argument to that class. So basically this is the way of specifying that this student class is inheriting person class. When we say inheriting, that means all these attributes that we have defined in the person class will be available in the student class as well. So here how that is going to happen, you'll notice this super keyword. So whenever you say super dot and then the method name like init over here and then keyword arguments. So super basically references the parent class. In this case it will be person, and then we are saying that execute the init method. So that's the init method over there, and in that it is expecting keyword arguments, and that is what we are passing over here, keyword arguments. Now once we do that, what it will do is it will initialize all these attributes, and you'll notice now when we are printing it over here, we are now also accessing the age attribute inside the student class itself. And when creating an instance of the student class, you'll notice we are also passing the attributes that are required for the person class. So here we have height, age and gender, and we have created two instances over here. And finally, when we'll be printing it, you'll see that the self.age will also be printed. So let's go ahead and run this now, and there you go. It says the student name is John, address is USA, age is 24, and for the other instance it says Matt and address is USA, age is 20. So that way you can create reusable components using inheritance based approach. You can have methods which are specific to a given instance. For example, you can have a student class and define a method over here, like we have get name and get address, and that instance will be calling that method only. Other instances or classes will not have that method, and still you can inherit from a common class, like over here we are doing it over here, person. So you can create another class. Let's call it as science student, and obviously science student will have a different set of methods, but still they are going to be persons and they will have similar attributes, height, age and gender. So you can take that approach as well and create reusable components using inheritance. This lecture will be taking a look at iterator methods in our classes. So we have explored the range method in Python, which is used to generate a sequence of numbers. Now in this one we'll be creating a similar function which will generate a set of numbers, and here you can see that we are saying that method as inclusive range, and we are providing 30 as the number, so it will print 0 to 30. Now that's the reason why we have named it as inclusive range, not just range. And here each number will be separated by a space when it will be printed inside the for loop. Now let's go to our class inclusive range. Here you'll see we have a constructor which is having this argument, and all we are doing is we are first of all finding out how many arguments are there, and the length is then stored in the num_args variable. Then we have two attributes like start and step. We also check for whether the user has provided any input or not. If not, we are throwing a type error and saying that at least one argument is required. Then we are checking if the number of arguments matches exactly to 1, then we are setting the stop at argument 0. So that means the stop value will be 30 in this example. Then we are having another attribute called next, which is going to have this value of start. So start, as you can see, will start from 0. So we have set two things, start 0 and stop at 30. Next item will be stored in this variable, and for now it is 0. Then we have this special method iterator, which is just returning the current value or the self. And here the next one basically checks if the self.next is greater than stop, then it will stop iteration. Otherwise, as you can see, it just keeps on incrementing and returning the value. And that is how we created our inclusive range function. Now if I go ahead and run this one, you'll notice it prints from 0 to 30, this example. So that is how easy it is to create an iterator class using these methods iterator and next in it in Python. This lecture will be taking a look at exception handling in Python. So whenever your program exits abruptly, you need to ensure that it does it more gracefully. And to do that, we have to learn exception handling. Now over here, you can see I have a method called main, and I'm trying to convert a string into an integer type. When I will execute this, you'll notice that it will throw an exception. And here you can see the exception is of type value error. It says invalid literal for integer with base 10, the value dump. And if you see this statement, it's a traceback, so it started from line number 4, that is when the main method was executed, and inside the main method on line number 2 this exception occurred. Now in order to resolve this, we can make use of try catch block. So here I can say try and then except value error. So here I am targeting a specific kind of exception, which is value error. So here when I run this now you can see that it just says value error exception occurred. So it's more graceful, and it just tells the user that there is an exception and one needs to take care of it. Now there are other types of exceptions as well. For instance, if I just go and try dividing a number like 5 or 15 by 0, in that case we'll get zero division error. So here I can have another except statement, and that will be covering zero division error. Now when I run this after saving it, and here you can see it says division by 0 exception. Now there are chances when you don't know what kind of exception has occurred. In that case, you can just go for a default except statement where you do not have to specify any exception or error type. So here we are just saying except, and then we are printing exception occurred. You'll notice we are making use of the sys library, and to do that we have to import sys, and here we can just make use of the exe_info method, which will provide us the exception. So now when we do this division by 0 error and we try to run this, you'll notice it says exception occurred and then it says division by 0. So exe_info 1 returns the message or the kind of exception that has occurred. Now if there is no error at all, for instance I'm just saying 15, and let's save this and run it. Now you can see that the else block got executed and it says execution complete. So that is how you can handle exceptions in Python. In the next lecture we'll see how we can create our own custom exceptions and handle them. In this lecture you can see that we have made use of raise statement to raise an exception. So in the previous lecture we saw whenever an exception occurred, at that point of time we were handling it, but here we are raising that exception. So if an argument is missing, we are saying a raise type error and says at least one argument is required. And when I pass this inside the inclusive range without providing the parameter, you can see that it says type error at least one argument is required. And here you can see the trace back. Now if you want to catch it over here inside the main method, you can do so by making use of the try except. So here we are saying try, and then this for loop gets executed. If an exception occurred, in that case it will catch that exception and it will simply print this line. So now if I go ahead and execute this, you'll notice it says argument missing over here. And if I go ahead and provide the argument and save this, you can see the output is printed over here. So that is how you can raise your exceptions and handle them using try except block. Strings are first-class objects in Python 3, and in this lecture we'll be exploring the same. Over here you can see we have a variable string s which is assigned a value hi there. Then what we are doing is we are performing some operations on that variable, like printing it out. First we are just printing the value as is, then we are applying upper function on that string, and we have another method called swap case which just reverses the current case of the variable. And finally we have formattings applied on the string, and then we are adding some value as well to it, like a numerical operation, 10 into 2. So if I run this now, you'll notice the first output that it says is hi there as is, then it's all caps when we are saying upper, and then swap case is just reversing the current case of this variable s, and finally we have hi there and then the value 10 into 2 added to the string. Now we can also overwrite strings. So let's say we have a class called revString like over here, and all it's doing is reversing the string that we have. So in order to get this working, all we need to do is type revString and here pass this as a parameter, save this. Now here I would like to highlight, this is the name of the class and this is the class name for string in Python 3. So when we are saying str, that is the class name of string in Python 3. And then we are just overriding str method with self, and here when we say self -1, that means it will reverse the order of the string. So here now when it will print s, then in that case you'll see reversed output. So let's save this now and run it again. So there you go, you can see this and the last one where we are printing s. Whenever we are applying some methods on the string, then this is ignored, but when we are just printing the variable itself along with formatting or just the variable without making use of any functions on them, then the output is what we have in our class. So it's reversing that output as you can see over here. So that was an overview about string objects in Python 3. In this lecture, we'll be taking a look at some of the common methods that the string object provides. So over here we have created an instance of string and the variable stores it as hi there. And then what we are doing is we are also storing the same value but in an uppercase in another variable called su. Here you'll notice we are just printing s, that is going to print hi there, where h will be capital and t will be capital. Then we have another method which when applied on the string capitalizes, so it will capitalize h and rest every other stuff will be in lowercase. After that we have s.upper, which just converts everything to uppercase. Lower, as the name suggests, converts it to lowercase. Title will convert it as we are seeing it, so every word's first letter will be capitalized. Then we have swap case, so whatever is the current case, that will be swapped. And then we have case fold. Now case fold output in general will look very similar to the output that we have for lower, but this works very aggressively and it also works on UTF-8 symbols. So if you have any special character, that also will be presented as a lowercase letter or character. Here I'm trying to show that these two will be different objects altogether because strings are immutable. So whenever you are doing some operation on it, a new string is created in memory, and that is what we will be showing you or demonstrating you with this example. We can also concatenate two string like we have over here s and su by plus symbol. So the output will be shown over here. Let's go ahead and execute it now. There you go, we have the output coming up. Hi there is the usual one, then capitalize, you can see the first letter is capitalized, then upper changes everything to uppercase, lower changes everything to lowercase, and then here this is the title case, hi there, and then we have swap case and case fold. Here these are the two IDs that you see and both are different. That simply shows that these two are different objects in memory. And here we are just concatenating s and su using the plus symbol. So these are some of the commonly used operations methods that you'll come across when working with string objects in Python. In In this lecture, we'll be taking a look at formatting strings. So here we have some variables like 10, 20, and then some large integers and decimal numbers assigned to these variables A, B, C, and D. What we are doing over here is we are formatting them either using the format method or the format literal. So here you can see when we are saying the numbers are and then two curly brackets are there. In this case, these are representing the two numbers A and B exactly in the same order. So A will be printed over here and B will be printed over here. Next, what we have done is we have made use of index position. So here you can see we are saying the numbers are 0, 1, and 0. Using this, you can repeat any number n number of times. So here in format, you're saying A and B. Now, as you're passing A as first value, so that's index value 0, B is going to be 1. Again, you're saying 0, so that will use A for this. Other way of formatting these numbers are assigning a variable name to the format method. So here you're saying format A equals A and B equals B, and then here you're saying A and B. That means this is going to print A and this is going to print B. You can swap it by changing the variable names over here, and the values will change here as well. Next, we have formatting numbers as large numbers are here. You usually format it with some comma separators to make it more readable. And to do that, all you need to do is inside the curly bracket, put a colon and then the separator using which you want to separate this number. Other than that, if you are working with a decimal number, you can use dot and then the number of decimal places you want after decimal, and F is for decimal value. So here we have D, and this is what we are printing. Other way of doing all these things is just making use of the format literal. So as soon as your print statement start, inside that you have F and then the string literal, the numbers are, and here you are placing the variable itself. So it makes it a bit more readable and less clumsy if you compare it to format, but it's up to you to use whatever you feel like is more easy or convenient for you. So let's save this now and run it. There you go. You have the output coming up. You can see this number is now formatted with a comma separator, and here these are the numbers with 3 decimal places. Here you can see we had 2546, but here we have 255. So that is how we can use format method or format literal to format a given string. This lecture will be taking a look at how we can split a given string and how we can join a list of string using some separators like comma or space. So here you can see we have a given string, hello world, learning Python 1 chapter daily. Now when we make use of the split method with an exclamation mark, what it is going to do is it is going to split it into two halves, hello world and then learning Python 1 chapter daily. So let's save this and try running it. There you go. You can see hello world as one item in the list and learning Python 1 chapter daily as other. Now if I go here and just copy this and just use the split method without any arguments, in that case you'll notice we have hello world learning Python 1 chapter daily. So all the spaces that we had, that is being used as separator, and when we called split method on that, it took that into consideration as the separator, and using that it created a list. Now that list, when assigned to a variable, strlist can be used to generate a comma separated value. So here we have strlist, and here you can see we are saying comma dot join, that is the method, and then we are passing this list to it. So output is a comma separated value we are printing over here, CSV. You'll notice it says hello comma world comma learning Python 1 chapter daily, and all of them have a separator comma in it. So that is how you can easily join a list of strings using specific character literals like comma I have used here. And to split, you can specify a given character, or if you're leaving it blank, spaces will be taken into consideration as a split character, and based on that it will create a list of strings. In this section we'll see how to work with files in Python. We'll be starting with how to open up a text file in Python. So here you can see we have a sample file created which is just having some numbers printed, and we will be exploring how we can read this file or open this file in Python. So here you can see we have a main method defined, and inside that we have the open method which expects the file name as parameter or file path as parameter, and it's just going to return you an iterator, and that iterator will have all the lines of the file. So here you can see we are just saying for line in F we are printing the line. Then there are a couple of optional parameters that we can provide in this method. So here the default mode when the file gets opened is read-only mode, and the default type is text. There are two types, text and binary. We'll be exploring that as well in upcoming lectures. And here if you have to specify the mode specifically, you can do so. So here I can say R for read, and it will read an existing file. W for write, it's going to clear any data that is there in an existing file, and it will rewrite it. If the file does not exist, it will create that file. Then we have append mode as well, so it will work with an existing file, or if the file is not existing, it will create one and write data to it. Otherwise, for existing ones, it will just append the data in the existing file. Now there's additional plus symbol that we can use along with read write mode. So here if I say R plus, that means we are saying make it writable as well. So that you can use, and then the default type as I mentioned is text, but you can also go for binary. We'll see its usage in upcoming lectures. So here let's go ahead now, and the default type as I mentioned is text, mode is read only. Let's save this and run it now, and there you can see the output is coming as 1 2 3 4 5 6, but there are spaces here, and in case you want to get rid of them, you can make use of the rstrip function. Now this rstrip function strips out all the white spaces including new lines from the end of the line. That's why we have rstrip. Let's save this now and run it again, and this time you can see there's no spaces in between, and the content of the file is printed over here line by line. So that was opening up a text file in Python. In this lecture we'll be taking a look at the text mode. So here we have a file called filesample.txt, and you can see that we have assigned it to a variable called source. So the source iterator is there, and we are opening it in read and text mode. Next, what we have done is we are saying open another file, name it as filesamplecopy.txt, and this time it is going to be opened as write mode, and the type is again text. Next, what we are doing is we are just looping through all the lines that we have in the source file, and then we are printing it line by line to this copy file. So we are specifying where to print. We are seeing file, and then we are specifying which file. So this is the file where all these lines will be printed, and finally we are printing ... every time a line gets copied. Finally we are just releasing it from the memory, the copied version of the source file, and the program prints done then. So now if I go ahead and run this, you'll see dots are printed and then it says done. Now if I show you over here, here we have the file samplecopy.txt, and this is the original file. So there you have all the contents now in the file samplecopy.txt.
and that is how we work with text types. Now in the next one we'll be taking a look at how we can work with binary types. In this lecture we'll be taking a look at the binary mode. So for that we have one file over here, python.png, as you can see, and this image is retrieved from the community website. Over here what we are doing is we're creating a copy of python.png. So the first thing we are doing is taking the main file python.png, and you can see that we are opening it in read mode and then binary mode. We will try to open this one as text. You might receive some errors and exceptions. So here we are opening it as binary file, and then we are creating another file called copy, and the name of the file would be python copy.png, and this you can see we are opening in write mode in binary mode. So here what we are doing is we are looping till the while loop has true value in it, and every time the loop goes we are creating a buffer of 10 KB, and if there is something in the buffer we are writing that buffer using the write method of the copy file. So copy.write buffer, and then we are printing dot every time this writes to the buffer, and if the buffer is empty, in that case the while loop will break. We are then closing the copied file and finally printing done. Now if I go ahead and run this, you'll see only one dot appears over here and it says done. So here we have a file now, python copy.png, and this is the file that we have just now created using python.png. So that was just an example of how you can work with text file as well as binary files in Python. In this lecture we'll be starting with built-in functions. The first one that we'll be taking a look at is the numeric functions that are built in Python. First of all, you can see that we have a string variable over here which has this numeric value 10 in it, and using the int method we are just converting string to integer type. Here we are just printing the values and type of the variable. So we are saying x is type of x, which will print string, and then the value that it holds. Similarly for y it is going to print integer and then the value 10. If we have a decimal or float value, so that also can be converted from string using the float method and just passing the variable to it as parameter. Then we have negative values, and if you just want to get the absolute value of it, you can do so using the abs method. And finally we have another method called divmod, which gives you the division as well as the remainder. So here what we are doing is we're dividing 10 by 3, so whatever is the remainder will be shown as a tuple. So if I run this now, the first thing that you will notice, x is a string and the value it contains is 10, then y is integer and the value is 10. Similarly, a is a string with a value 10.0, and then we are converting it and assigning it to b as float 10.0. Then d is an integer with negative value -47, and when we are saying absolute, it is converting it to 47, but the class still remains integer. Then when we are making use of divmod, we're getting a tuple as a result, and the value you can see 3 is the quotient and then 1 is the remainder. So 3 times 3, 9 plus 1, 10. There's the result that is showing. So there was numeric functions in Python, and you can get a look at it in detail on the docs.python.org website. In the next one we'll be taking a look at string functions. In this lecture we'll be taking a look at some of the common functions available for a string, and here you can see I've created a class called dummy, and the constructor initializes the variable n with the value that we are passing. And then we have two methods over here, repr and str. So usually when we print the value, the str method gets called and it prints the statement that we have defined. And for repr is basically used to print the best representation of a given variable in string form. and here you can see we have customized it. If we do not do that, and let's go ahead and delete this for a moment, save this, and let's run this now. So here you can see when we are printing X, it is saying str the number of dummy is this, and for other two you can see that it is just printing the class object and with its identity. But if I give this value definition REPR the number of dummy is, in that case when you run this, you'll notice for both these functions REPR and ASCII, same result is getting printed. And the only difference between REPR and ASCII is that ASCII will only print ASCII character codes, and REPR will take care of the Unicodes as well. So that's the only difference between REPR and ASCII. And that was some of the commonly available methods for a string in Python. In this lecture, we'll be exploring some of the common methods available for container objects. Container objects are sets, lists, tuples. So here we have a set, as you can see, 1, 2, 3, 4, 5, 6, and that's assigned to a variable I. Then we have created another variable j, and there we are assigning this set. So if we print both of them, they will have the same value. Now we have another method called reversed, which basically returns an iterator, and the result set will be reversed. So instead of 1, 2, 3, 4, 5, 6, it will be 6, 5, 4, 3, 2, 1. And if you want to convert that to a list, you can make use of the list method, and that will be converted. And here we are assigning it to a variable L. Then we have some of the methods which work on containers, like len, which will give you the length, that is the number of items in a given list or set or tuple. And then we have sum method, which when applied basically returns the sum of all the integers that are available in the set. And if you want to find out the maximum or minimum, then you can make use of max, min respectively. And if you want to go with Boolean type of set where the values are either 0 or 1 or all 0. So here when we say all result set, basically this is going to return false because all these values are false. And if all of them is converted to 1, this is going to return true. And another method for the same is any. So if any of the values is set to true, for instance over here, if I just set it to 1 and then save this, and when we'll run this one, we'll get the result as true. Then we have another method called zip, which basically concatenates it based on the index position. So we have 1, 4, 2, 5, 3, 6. When we'll use zip and print it like this, it will print it 1, 4, 2, 5, 3, 6. Next we have enumerate, which when applied on string sets basically prints the index as well as the value. So here when we are saying ABC and we are printing, it will print the index value 0, then A, 1, then B, 2, then C. So let's go ahead and execute it now. And here you'll see the first is the set that we defined I, then J was basically assigned I itself. Then we had K as reversed, so that is being printed over here. Then we have the list, reversed list, which was used from the reversed iterator, 6, 5, 4, 3, 2, 1. The length method now returns the length, that is total number of elements in the list, that is 6. Sum of these numbers is 21, max number is 6, min is 1, and then as I mentioned any, and here you can see 0, 1, 0. So any basically is returning true because there's at least one value which is true in the set. And then we have the zip 1, 4, 2, 5, 3, 6 and enumerate as 0, A, 1, B, 2, C. If I make all the values of this as 0, and here if I make use of the all method and save this and now run it, you'll notice it is printing false. So these were some of the common container methods in Python. In this lecture, we'll be taking a look at some of the common methods that are available for working with classes and objects. So here, as you can see, I have created an integer variable with value 42, and when I'm making use of the type function on it, it will return the type of object it is. So let's go ahead and run it and see it in action first. So here you can see it says 42 and then the type is class integer. And here we have another method which just ensures you whether a given object is of a specific class or not. So here we are saying is instance, and then we are passing the variable x, which is integer, and we are saying is it integer. If it is integer, it is going to return true, and that's what we have when we are saying print r. So there we have it over here, print r as true. And then this id of x that is printed over here is the id of this particular variable in memory. So when you're creating any object, it gets a unique id in the memory, and when you print it using the id method, that's what you get. So these are some of the commonly used methods for classes and objects in Python. In this lecture, we'll be covering modules in Python. So here, when we are on the documentation link, docs.python.org, you'll find the documentation related to everything that Python covers. And if you just look a bit closely, here we have data types, numeric and mathematical modules, and everything below that, they're all modules. And if I have to pick one module which is very commonly used, that would be this sys module. Now this module has certain functions using which you can find out things like version information and platform. There are other modules as well which we will be demonstrating in this one, and there will be OS, random, and datetime. So basically module covers certain set of functions which belongs to a specific namespace, you can see. So if you're talking about datetime, you will know that anything related to datetime will be covered under a module called datetime. Similarly, if you have to generate some random numbers, you'll know that there's a module random which covers that feature. So it's just grouped inside a common name, and that is what we refer to as module. We'll see how we can create our own modules in upcoming lectures as well. So here we'll be starting with the sys module. The first thing that we need to do is make use of the import statement and then say sys. Next, what we have to do is just use the module name that we have defined over here, and after that use the property, attribute, or method that it has. So here we have version info, which gives the version information. Then we have platform. So here we are just printing those variables. If I run this now, you'll notice that we have the sys version info. It has this major version, minor version, micro version, release, and serial. That is what it shows as version. Then we have platform, and you can see the platform is Windows 32. Next, we are making use of the OS module, and this gives you certain attributes like name. Then you have methods like get environment, and if you pass path to it, you'll get the path attribute on the Windows environment. Then you have to get the get current working directory that you can get using the os.getcwd method. So here, that is what you're viewing. This is whole path thing. Then this is the current working directory, and name you can see as NT, new technology. And if I further go ahead, we have this random module. So here we have used the random module, and for the random module we have another method called randint. So if you pass start and end value to it, it will generate a random value within that range, and that is what we are printing over here. So every time you run this, you'll get a different value. Next, we are making use of the datetime module. So here you can see we have just imported datetime, and all we are doing is getting the current time inside this variable current time. So we're saying datetime.now, and then we are just specifically printing out few things like year, month, day, hour, minute, and second. So this is how easy it is to use an existing module in Python, and I would recommend that you visit the documentation link that I just showed you in this lecture, and it will be very helpful for you if you find out that there are modules which are already existing that does the job which you are looking for. then better go ahead and take a look at the documentation, and if it's not there, then only you go and create your own module. In this lecture, we'll take a look at how we can create our own custom modules and use them in Python. So the first thing that we'll be doing over here is creating a custom module. For that, you need to create a simple class. As you can see over here, I've just created a class called age, and inside that I have a method called getAge, which is expecting a parameter year. And here I'm making use of the datetime module, and using that datetime module, I'm just fetching the year and I'm subtracting the year that user has passed, and then I'm printing that. That's pretty much it, what we're doing over here. Next, coming on to the modules custom.py, you'll notice I have imported it over here. So you just have to make sure that your name of the file is actually the name of the module. So here you're saying import age, that means the file should have the same name, age. And inside that you'll see this is the name of the file, and then this is the name of the class, and then this is the name of the method which we are calling. Here I've just passed 1983 as year, and when I'm going to run this, you'll notice the output is coming as 36. So that was just a quick demonstration on how you can create a custom module and use it in your program like we have done over here. In this lecture, we'll be starting with databases. Python by default comes with SQLite database, and the SQLite is cross-platform database. So here in this lecture, we'll be taking a look at how we can connect to SQLite, how we can create a table, insert some records to that table, and how we can select those records, how we can count the total number of records in table, and finally how we can drop that table that we have created. So starting with connecting to the SQLite database, the first thing that we need to do is creating an instance. So we'll have to import SQLite 3. Once we have done that, we'll be making use of SQLite3.connect, and here this is the name of the file that will be created. So I'm just saying it as Python database, so short form for that is pydb.db. Obviously db is the extension of that file. Then we have to create a cursor, and for that we'll make use of the db instance. So db.cursor will return us a cursor. Using that cursor we can execute queries, and these are simple SQL queries. So here what we are doing is drop table if exists user. So if user table already exists, it will drop that, and it will create a fresh. So here we are saying create table user, and then here you can see we are specifying the primary key id, which is of data type integer. Then we are saying string first name and string last name. We are then closing this whole thing, and next statement that we are doing is inserting records in that table that we created. So here we are saying cursor.execute and then insert into user, and then you can see two parameters, string comma string, that is for first name and last name respectively, values John and Doe. You don't have to specify the value for column id because that's an integer primary key and it will have an auto increment value. Next we are just committing it using the db.commit. So remember, cursor is used to execute the queries, but when you have to commit this whole thing, you need to go with the db instance, so db.commit. Next what we are doing is counting the total number of records that we have inserted. Obviously for now we are just inserting one record, so we are saying over here cursor.execute select count star means all, so select count all from a user table, and whatever is the result we are assigning to count. So for that, cursor provides a method called fetch1. So here if I show you the IntelliSense, so here we have fetch all, fetch many, and fetch one. In this case we have to use fetch one, and then at index position 0 the count value will be available, and that is what we are assigning to the count variable, and then we are printing it out. Next we are looping through all the records that are there in the user table and printing it row by row. So we're saying for row n cursor.execute select all from user, and then print row. And finally, here I've commented this one for now because I need to show the file that will get created, pydb.db. And here what we are doing is cursor.execute drop table user, and then finally closing it. Here I have made a mistake actually. So the first name column will come first, and then the data type of it will appear, and same goes with last name as well. So here we'll have that, and let's save this now. And here we'll have to specify the first name and last name. And here you can see the output is now coming up as connecting to SQLite server. That is the first statement. Then it says create DB. Now when it says create DB, if I show you the files, the name is pydb.db. So here you can see this is the file that is created, py.db, and the contents obviously cannot be shown over here, but you get the idea that this is a file that gets created, and everything that we are inserting, updating is inside this file now. So that's what it is when we say db is equal to SQLite 3.connect by db.db. Next, what we are doing is inserting some records and committing it. So insert record is this, first name, last name, John Doe, and here we are saying total record count 1, and then we are doing the select operation. Here you can see the row is printed as a set, 1 John Doe, and 1 is the primary key. Then we have the drop. So for dropped, all I need to do is just write drop table user. Now if I execute this, it has deleted that table, and every time when you will run this one, it is going to delete the user table if it exists and then create it fresh. So that was how to work with SQLite in Python. In this lecture, we'll be taking a look at how we can work with MySQL in Python. So the first thing that you need to have on your system is MySQL installed, and you can do that by visiting the mysql.com/downloads link. We're not going to cover how to install MySQL on the system. We'll be demonstrating how we can connect to an existing MySQL server. So I already have MySQL installed on my machine, and here you can easily download it and install it on your system. Once you have done that, the next thing that we need to do is installing the MySQL connector. So here we have connector for Python, and you can select the operating system and the version based on the kind of OS that you have, like 32-bit or 64-bit. You can choose to install the connector. Here I'll be going with the 32-bit version. Just click on the download link to get started with the download, and here you can just skip this, and here you can see the connector MSI file is being downloaded. Next, you just click on this once downloaded. Once the installer has launched the wizard, you can just go and click on next, and here you can just go ahead and click on next one more time, and everything will be installed with the permission, and there you go. It has been installed. Now click on finish. The next thing that we need to do is open up Visual Studio Code, and here try importing this MySQL connector and save this and try running the script now. And here you can see the script ran successfully without any error. That means your MySQL connector has been installed successfully. Next, what we need to do is, so I'll be rewriting this whole thing so we can have it over here like this. The first thing that we're doing is we're giving it an alias, MySQL connector as MySQL, and here we'll have to provide the host, which is obviously localhost. User is root, and in my case the password is this. Now once we have this established, the database instance has been created, we can save this, and the next thing that we'll be doing is create an instance of cursor class, which is used to execute the SQL statements in Python. So here we have the cursor instance using db.cursor, and next we will be creating a database called pyuser. So here we are saying cursor.execute create database pyuser, and then we are making another SQL query that is show databases. So if this database has been created successfully, using cursor.execute show database, and then finally cursor.fetch all will provide us all the databases that we have in MySQL Server that's installed on this machine. So let's give it a run now. And here you can see it says can't create database by user, database already exists. So what we'll do now is we'll just comment this line and let's give it a run again. And there you go. You have the information schema, CMS development, courses app, MySQL, PyUser, and test databases in the installed MySQL Server. So we have seen how to create a database, how to list all the databases that are already existing in the MySQL Server. You can also loop through it one by one using the for loop. So here, let's clear the output, and there you go. You have all these databases printed now. Now let's go ahead and see how we can create a table inside a database. So till now, here we provided 3 mandatory parameters. The one that is required now for creating tables is the database itself. So here we'll say database is equal to, and the name of the database that we just created was PyUser. Let's save this now. And once we have the connection string sorted, the next thing that we need to do is right after the create database PyUser, you can have this create table users, and here we're just having 2 columns, name and username. Let's save this now. And just like we printed all the databases, here we'll be printing all the tables that we have inside the current database. So all we are saying is show tables, fetch all. The values will be inside the tables, and we're looping through that table collection. So let's give it a run now. And here you can see the users table is now listed as part of the output. One thing that we have not done in our create statement when we were creating the table users is that we have not defined the primary key. Now any table when defined must have a primary key. So what we'll do now is we'll just remove this line, and we'll first of all drop that table that we created earlier, and we'll again create the users table. This time we'll be including one more column called ID, and you can see that it's set as not null auto increment primary key. So these are the attributes that a primary key must have. It should be not null. Usually it's auto incremented unless you are not doing it from an external script or something. And then we have the column names as usual, name and username. Now once that's done, this table will be created again and it will be printed just like we have currently in the output. Now if you want to know the metadata of a table or the structure of a table, you can do so by using the query describe. So short form for that is DESC. That is describe users. So when we do that, here just after the user's name table, we have the structure of that table. So it says ID, then the data type, whether it's null or not, then whether it's a primary key or not, auto increment is set to true. Then for other columns, name, varchar, null yes. Then we have username, another column name, the data type of it, and whether it's set to null or not. So you can get the structure of the table using this command. Now let's go ahead and add some rows to your existing table users. So here you can see we are saying insert into users, the name, username, values, both are string. That's why we are making use of %s. That's for string. We use this in MySQL. After that, all we are doing is we are specifying the values. So here you can see I'm just specifying first and last name, John Doe. And then we are saying cursor.execute, then the query is there, and the values that query needs, values. Finally, we are doing db.commit, and once you do this, the changes will be applied to the database and records will be inserted. Next, we are saying cursor.rowCount. Using this, you get the total number of rows that has been inserted using the cursor, and it will just print total number of rows records inserted. So now if I run this, you can see it says 1 record inserted. And if I have to see how many users have been inserted inside the users table, I can do that using the select query. So here I'm saying select all from users, then cursor.execute. Finally, using fetch all, I can get all the records that are there, and then looking through each one of them will print over here. Now as I'm deleting the table right when this script starts, that's the reason why it will just have one record every time I run this script. So if I now run this, you'll see John Doe as the user inserted in the system. And that's pretty much it about how you can connect to MySQL database, how you can create databases, create tables, get the structure of that table, insert some records, and select as well. So you have to have some knowledge of MySQL as well along with Python to work with MySQL with Python.